In question 1.1, the following table shows the balance on a random sample of 150 customer credit accounts. So the question mentioned that it's a sample question and the total frequency is 150. With the 5 items of balance number of account, we need to first find the cost mark. And the cost mark of the question is 50. But how can we find the cost mark? It's because lower boundary is 0 and upper boundary is 100 and divided by 2 is 550. Just for example, another example, lower boundary is 100, upper boundary is 200 divided by 2 and 115. So now we can find the cost mark. So now we need to calculate the mean. Mean. In sample question, we use these simples as the mean of the sample question, and we need to find the total of the number of accounts times the cost mark, and divided by the total frequency, which is the n. So in this question, we need to cost mark is 50, and we need to time 36. 150 times 50. 700 times 12. And the lower part, we need to put the total frequency, which is 150. So now we should calculate that the mean of this question should be 258. Next question. Now we need to find the mole. Mole can be found by the largest frequency of that cost, which is 50, has the largest frequency. But in scripted data question, if we want to find the mole, the equation should be and L1 is the lower boundary of the module cost, which is 100. And D1 is represent the frequency of the module cost with the minus the previous cost, which is 50 minus 36. And D2 represent the frequency of the module cost minus the following cost, which is 50 minus 25, and should be always positive. Then the upper boundary cost is 200 because this is 200 and minus 100. Therefore, correct to 2 decimal places. So now we can find the mean. Okay, next question, standard deviation. So standard deviations, the equation should be n minus 1. It's because it is a sample question. So we need to minus 1. So we now we have the cost mark. is 36 is 50 minus the mean is 258 squared and 150 minus and the total frequency 150 minus 1. Therefore, the answer should be correct to 2 decimal places. Therefore, we can find that the standard deviation of this question is 202.51. So this is the end of question 1.
I'm Oh Sydney, and I'm talking about question 1.2. As we can see from the question, it provides us with a frequency distribution table about 42% and their use of amount of time to assemble the dresser. As for question A, it asks us to compute the mean and median of the length of time. So I have drawn a simple table which includes the midpoint and the accumulated frequency for each class limits. For the mean, we should first find the sum of the data, which is we can see at the first line, and divide it with the total frequency, which is 42 workers, and we would get the mean answer for 7.3333 minutes, round to 4 decimal places. As for the median, since there are 42 workers, the median would be at the data for the 21st and 22nd workers, which is in this class. So, as we can apply with the formula for the median, we should first add the lower quartile of the class, which is 6, and add 42 total frequency over 2 and minus 13, which is the previous accumulated frequency of the previous class, and divide it with the frequency, which is 14, and then we should multiply it with the upper boundary 8 and minus lower boundary, which is 6, and we can get the answer of 7.1429 minutes, rounded to 4 decimal places. For question 1.2b, it asks us to compute the range and the standard deviation of the length of time. As for range, we can see that the highest minutes will be 40 minutes, and the smallest amount of time would be 2 minutes. So the range would be 40 minutes minus 2, which we can get the range would be 12 minutes. As the data is a sample data, we should find the sample standard deviation, and we can see the calculation. First, we would, for each, the frequency of the class, and then we would find the midpoint and minus the mean, and square it, and repeat the steps. And then, as it is sample SD, we should divide it with the total frequency of 42 and minus it by 1. So after the calculation, we can find that the sample standard deviation of the data would be 2.6102 minutes, to round to 4 decimal.
For question 1.3, there are 20 ungrouped data, and they are listed in ascending order. For the population mean, We add up all the data and divide it by the number of data, which is 20, like 5.24 plus 6.02, and we add up to 15.42. We then divide it by 20, so we get the answer, which is 9.919. And for the median, as there are 20 data, so the median is we add the 10th and the 11th of the data and divide by 2. The 10th the data is 9.45 and the 11th data is 9.61. We add up these two data and divide by 2. So we can get the answer 9.53. For the standard deviation, the first step is using each data minus the mean, and then we take square. Like the first number, 5.24, minus the mean, 9.919, and then we take square. The second data, 6.02 minus 9.919, and take square. We add up all till the last data, 15.42 minus 9.919, and take square. We then divided it by 20. So this is the variance. In order to find the standard deviation, the last step is to take the square root. So we can finally get the answer, which is 2.8228, correct to the 4 decimal place. So this is the explanation of question 1.3.
Hello, I'm Lam Chom and I'm going to report question 1.5. The number of cars sold by each of the 10 salespeople in an automobile dealership during a particular month as follows: 2, 4, 7, 10, 10, 10, 12, 12, 14, 16. And in this question, we have to find out the mean, standard deviation, range, interquartile range. So at here we have totally 10 numbers. And for the A part, we have to find out the mean. So we have to add up all these 10 numbers together. And then divided the sum by 10. The answer is 9.7. For the part B, as the question doesn't mention about it is simple distribution or population distribution, so I will use the method of calculating standard deviation of sample distribution. So the standard deviation is equal to 2 minus 9.7 black cat square plus 4 minus the mean 9.7 black cat square. And the following numbers is using the same method as below. Add up all together and divided by 10 minus 1, and we use a square root. So the answer is 4.3217794969. So about the range, it is the differences between the extreme number. So we can find that the biggest number here is 16, and then the smallest number here is 2. So 16 minus 2 is equals to 14. About D part, we have to find out the 25% of the data and the 75% of the data. Interquartile range is the differences between 75% of data and 25% of the data. So we can find out the 50% of the data is here, and then the 75% of data is 12, and the 25% of the data is 7. So 12 minus 7 is equal to 5. Thank you.
Hello, I'm Wang Weibi. I'm going to explain the question 1.6. The weight of a sample outgoing packaged in melt wood raised to the nearest ounce are found to be 21, 18, 30, 12, 14, 17, 28, 20, 16, and 25. And to determine the mean standard deviations range in the quarter range. I already done the answer, so I'm going to explain it. For the part A, to find the mean, to add all those tens data and add it up to 21 plus 18 and add it up until 25 and divide it by tens because there is total 10 data and the answer is 20.1 ounce. And for the part B, to calculate the standard deviation, and how to do it is since we already found the means, and for 21 is reminded the means and square it and add it up. 18 also minus 20.1 and square it and until 25 minus 20.1 squared and divided by tens minus 1 because we are finding the sample standard deviation and add the square root and the answer is 5.952590473 and round off the answer is 5.95 ounce. And for the part C, to find the range and the quartile range, we need to record the data. So after recording the data is this 12, 14, 16, 17, 18, 20, 21, 25, 28, and 30. To find the range is used to the maximum values minus the minimum values. So the range is 30 minus 12 and the answer is 18 ounce. And for the last part is to find the interquartile range. How to find the interquartile range? First, we need to find the median first. The median is 18 plus 20 to divide by 2, and the answer is 19 ounce. Also, you need to find the Q1. The Q1 is the median of the lower half data, and which is 16 ounce. And the Q3 is the median of the highest half data, with 25 ounce. To calculate the interquartile range is Q3 minus Q1, which is 25 minus 16, with equal to 9 ounce. So this is the end of the question 1.6. Thank you.
Question 1.7. Following are sample surface time data for completing a specific task for Team A and Team B. Calculate the coefficient of variation for Team A and Team B and interpret the result. So first of all, the formula of coefficient of variation is the standard deviation divided by mean times 100%. So we have to find out the sample mean of Team A and Team B first. The formula of sample mean is the summation of data divided by the total number of data. So for Team A, is equals to x plus 10 plus 10 and add up to the last data 20 divided by 10. So the answer is 12.9 minutes. For Team B is equals to 9 plus 12 plus 18 and add up to the last data 33 divided by 10. So the answer is 22.3 minutes. In the second part, we have to find out the sample standard deviation of Team A and Team B. The formula of sample standard deviation is the square root of the summation of data minus mean square divided by the total number of data minus 1. So for team A, is equals to the square root of x minus 12.9 square plus 10 minus 12.9 square and add up to the last data, 20 minus 12.9 square divided by the 10 minus 1. The answer is 3.9567 minutes. For team B, is equals to the square root of 9 minus 22.3 square plus 12 minus 22.3 square and add up to the last data, 33 minus 22.3 square divided by 10 minus 1. So the answer is 7.5432 minutes. So in the third part, since we have found out the sample mean and sample standard deviation, we can finally calculate the coefficient of variation. For team A, it equals to 3.9567 divided by 12.9 times 100%. So it's equals to 30.6722%. For team B, it is 7.5432 divided by 22.3 times 100%. So the answer is 33.8260%. So as we can see, the CV of team B is larger than the CV of team A. So the service time for team B to complete a specific task has a larger level of dispersion around the mean, and the data of team B has larger variation than team A.